Okay. Well, I hope everyone's not too tired after lunch to think about Ruby and code and all that fun stuff. I will warn you, I try and make very bad jokes. I understand that, but this time my boss is in the room and I worry that if you don't laugh at them, I might lose my job. So please find me funny. So today we're going to be talking about Marshal. Now, I apologize. Sorry, not sorry. This is a really terrible pun. I have not seen the movie. I know the name. But do you know how hard it is to come up with funny titles for conference talks about binary data serialization formats? It's a challenge. A little bit about me. I am at SE Giddins pretty much everywhere on the internet. My name's Samuel. I'm a maintainer of Ruby Gems and Bundler and rubygems.org, and I've been contributing bugs for over a decade at this point. In my day job, I'm the security engineer in residence at Ruby Central, sponsored by AWS, focusing on the security of the Ruby and Ruby Gems ecosystem. But that's not entirely what we're going to be talking about today. We're going to be talking about this. This is the subject of an entire 30-minute talk, and I fit it onto one slide. Marshal. So a show of hands, who here has used Marshal? Yeah, a fair number of you. Now let's do that again. Who here has been told that Marshal is bad and you shouldn't use it? Pretty much the same people. Great. So today we're going to explore Marshal in some more detail. We'll look at the good and, yes, the bad and see what we can learn from it. So to start off, I went ahead and spent way too long this morning figuring out how to use hexdump and printed out some Marshal for us. Here we go. Here's a hexdump of a small Marshal document. And we are going to walk through this byte by byte. So here we are. Let's start off. Byte number 0. We have the Marshal major version number, 4. The minor version number, 8. And before you ask, 4.8, how old is that? The answer is very. Moving on, we can now look at objects. So there's an I. Byte number 3 is an I. That gives us the type of our next object. We then get, so I, what does that mean? It means we have an object with instance variables in it. Okay, next byte. So inside of the object with ivars, we have the type of the object that has the ivars, and it is quote. Sorry, it is double quote. Now, okay, you could probably guess that that means it's a string. Okay, so we're through 4 bytes now. Next, we have the length of the string, which in hex is 0x16, which means that, of course, the length of our string is 17 bytes. I know everyone here was thinking that, and we're like, Sam, you didn't have to tell me that. That was obvious. So integers in Marshal use a packed variable length encoding, just so if you're looking at the hexdump, you have more trouble understanding what you're looking at. And then finally, we have the contents of our string. Hello, RubyKaigi. Okay, we just sped through a whole bunch of bytes there. We're almost at the end now. So now we're done with our string. We're back to our object with ivars. And we can see that the number of ivars is 0x06, which means we, of course, have one instance variable. Next field, we have the name of the instance variable, which is going to be a symbol, which is denoted by a colon. Okay, that makes sense to us as Rubyists. Colons mean symbols. And the length of it is 1 byte. And the name of the instance variable is E, which on a string means encoding. It's a special instance variable name that you can only set on strings, because notice what's missing. There's no @ sign. And then the value of the E instance variable is a T, which means true. Okay. Who had fun just reading byte by byte? Yeah. Woo! Yeah. That'll really wake you up after eating. So here's maybe a more helpful way of looking at that same tree. We have our Marshal major version, minor version. We have an object with ivars, which has a string in it, which then the string is followed by a symbol of E, and then true. Now, how would you feel if I said that was a really simple Marshal stream? So, okay, while you sit with that and just worry about how much more complicated this whole thing can get, complicated enough to warrant a conference talk, of course, let's rewind. So Marshal is a binary file format that has been supported in Ruby core since forever. I was too lazy to look up how long it's been around for, but I'm pretty sure that we have been on Marshal version 4.8 since before I started doing Ruby, which was a pretty long time ago at this point. And okay, we use Marshal to serialize a Ruby object graph into a binary format. Great. Now, the reason I care about Marshal is it's used in certain places in Ruby gems due to legacy reasons. And those legacy reasons are actually kind of also current reasons, which boil down to the fact that Marshal is the only binary format that you can read in Ruby without requiring any gems, which is kind of important for Ruby gems. So let's set that aside. This is why I started looking into Marshal back in September and started this whole journey. Marshal belongs to a family of what are called tag length value formats. There's a tag that tells you how to interpret the next bit of data. There's a length that tells you how long that piece of data is, and then the value, which is the piece that we care about. Compare that to the formats that we're more familiar with. There's JSON, which is like a delimited format. You have opening braces and closing braces and quotes around things, things like commas. You also have context-sensitive formats such as YAML, where where you are in the document changes how you interpret it. Things like how far indented are you? So, okay, tag length value. Let's have a look at the different tags that are in Marshal. Take a deep breath. So we have strings, we saw those. Nil gets its own tag. There are symbols, we already saw those. There are links to symbols. There are links to objects. False. Objects with instance variables. True. User-defined Marshal classes. Arrays, floats, integers, big nums, objects, user-defined objects, hashes with default values, extended objects, classes, modules, class or module, data, regular expressions, structs, And user class, it's a lot of types. It's not the simplest format. Additionally, as I mentioned earlier, there is a special encoding for integers, which took me a while to implement properly. But what's cool about it is we can encode really small numbers in a single byte, and we can encode everything up to 32-bit integers in up to 5 bytes, where the first byte signals the sign and the length of the integer, and the other bytes are, the integer. Oh, I thought that was going to look even smaller on the screen. If you ever wondered how to decode an integer in Marshal, there. I'm not going to walk through it. Suffice it to say, it allows us to encode really small numbers using fewer bytes and bigger numbers with more bytes, which people have decided is a valuable thing for some reason. Turns out small numbers occur quite frequently in large documents, and big numbers are less frequent. And if you have like 0 and 1 repeated a bunch of times, it helps to store them in a single byte, or so I'm told. There are also fun features that we saw from the tag list, like symlinks. There are links in Marshal that can point to both objects and symbols. So we can see here I'm Marshal.dumping an array with some repeated strings. Let's assume, I have not shown it on the slide, but we have frozen string literals enabled. And we can see in the output here, our 2 strings each only show up once, even though they're repeated in the array. That's because of those @ signs that are showing up in the hex dump. Those are links to the repeated objects. So let's say you have, hypothetically speaking, a file that has a list of every Ruby gem and that gem's version and platform. And all of those get repeated a bunch. Not having to spell out those strings saves a bunch of space. As I said, fun feature. And yeah, if we look at that same document here, we can see, okay, we have the array, and the array has 2 objects with ivars, which are strings, and then we have object links that point to those repeated objects. So the object at offset 1 here is high, the object at offset 2 here is rubiest. If you're curious, the object at offset 0 is the array. Basically, you just scan through the document and every object gets added to the list of objects, and then you can refer to them. Now, as I said, I am a security engineer, so my focus and the reason I ended up writing stuff around Marshal was Marshal as a file format and also as a module that ships inside of Ruby was not designed with security over arbitrary inputs in mind. There's this basically list of common web application vulnerabilities called OWASP. I'm going to quote from smarter people than me, saying basically it's good to avoid native deserialization formats. If you switch to a pure data format like JSON, or you can tell this who wrote this because it thinks XML is a good thing, but by switching to a pure data format like JSON or XML, you lessen the chance of custom deserialization logic being, put politely, repurposed towards malicious ends. AKA, you're less likely to be hacked, owned, have a data breach, be held ransom, etc., all those bad things. Additionally, the US government's National Vulnerability Database says data which is untrusted cannot be trusted to be well-formed. Malformed data or unexpected data could be used to abuse application logic, deny service, or execute arbitrary code when deserialized. That's a list of very bad things. And so in recent years, the advice is to not use Marshal. Use other formats instead, things like JSON or not XML. You'd be thinking, how could this be unsafe? You just showed me a bunch of bytes, though nothing could be safer than a hex dump of a bunch of bytes. So now we get into why I spent a month looking at Marshal in the first place. In Ruby gems, we load what are called quick specs from a gem server. If you want, you can download one of them at that URL. You're going to have to gzip or like zlib.inflate the contents of that because it's a deflate stream, and inside that there is a Marshal document with a gem specification. Now, if you marshal.dump a gem specification, it looks a little bit like this. This is just gem specification.new being dumped. We're not going to walk through this one byte by byte. I'll spare you. But here are the important bits. There is a U, meaning we have a user-defined class. We can see that gem specification is the class name. And Marshal then loads the class from the constant name, and because the tag, the type of the class was U, we call _load on the class with the binary string that was next in the document. Now, what would happen if in that document, instead of being told we have a gem specification, we have something like just throwing a random class out there, an action dispatch routing route set named route collection, or an ERB buffer, or a random class that someone wrote that when you call initialize on it will call methods on arbitrary methods on a class based on what instance variables are set on it. This might sound hypothetical, but about 10 or 11 years ago, there was a pretty big vulnerability announced in Rails that went through this exact thing, but with YAML. If you deserialized a specially formatted document that contained an action dispatch routing route set named route collection, you could execute arbitrary code. This type of vulnerability took rubygems.org down for like a week back in the day. Really bad stuff could happen. You could, let's say, dump all of the environment variables that someone has set, or make requests and send things in their environment out, or install arbitrary software on their machines. Bad stuff. And you could then use marshal.load to execute arbitrary code, despite the fact that in Ruby gems, we're only expecting a very benign gem specification. Now, it makes sense that we've moved away from Marshal because of this, but it's sad because it's like a pretty cool format by itself, other than the list of 25 different tags. That's pretty long. It takes a while to implement. So what's good about it? It's more compact than if you, say, gzipped a JSON or CSV file. You can deduplicate objects. But what if we could make Marshal safer? And, given it's used in Ruby gems, I wondered, could we do it? Could we make Marshal safer? Unsurprising answer here was yes, we could. So I wrote a bunch of gnarly code, which was heavily inspired by Sykes' safe load method, a method that was introduced due to that very same Rails YAML vulnerability I was talking about a minute ago. And the way it works is a little like this. We call a new method instead of marshal.load, gem safe marshal.load. We pass it an IO and a list of permitted classes. We parse that stream and create a tree of objects out of the stream. We then walk that tree, transforming each of the elements in it into Ruby objects. And for objects in IVARs, we check, are they permitted? And we make that check before we do that transformation. We then sort of close our eyes and hope we did it all correctly, tap our heels 3 times, and return the root object in the document. And so, like any good compiler engineer does, I ended up writing a parser and a visitor. We're going to skip over the parser bit because there are some good resources if you just Google Marshal file, Ruby Marshal file format, as I have done several times. But if you think you know any corner cases about Marshal that I don't, please come and try and stump me after the talk, and then we can commiserate about how well we know Marshal. But the visitor is where all the cool safe stuff happens. The idea is we have a root visitor class. It knows how to walk the tree. We've implemented methods that say, hey, this is how we descend through an array. How do we walk an array? Well, we visit each one of its elements, and so on. And then we wrote a visitor that, when it goes and visits stuff, will return a Ruby object. If you've ever contributed to Psych, this code will probably look very familiar. It's basically the same exact signature. But our to-Ruby visitor gets a list of permitted classes, and a list of permitted symbols, and a hash of permitted instance variables for those permitted classes. And then, going off of our earlier example of a gem specification, loading a user-defined object will resolve the class, which means, okay, we have a symbol. We'll figure out what string that symbol is going to be. We check, is it permitted? If it's not permitted, raise an exception that says, this isn't permitted. We ensure that the symbol is something we're allowed to create. We then get the constant. We load it in. If it's undefined, we say, hey, it's undefined. And then we go and call _load on it. But along the way, we've done a good amount of checks in here that don't happen if you're just calling marshal.load. And in this way, we can check if the class is permitted before we call load on it. And we can check that the constant is permitted before we const get it. And we do this for all the places where mischief could happen. Things like creating a symbol, because you could create a bunch of symbols to DOS a process. Or loading a constant, because you could use it to load a class that does something bad. Or if you can find a module that has overridden constant resolution, you could make shenanigans happen. Every place we call a method, we make sure that the method is defined. And setting an instance variable, we check, hey, do we know about this instance variable on this class? Are we expecting it to be set? Helps prevent setting instance variables that the class isn't expecting. Maybe the class has a memoized instance variable, where if it's set, it'll avoid recomputing things. found a CV in rubygems.org that had an issue like that, but loading from YAML. Now, Marshal has a lot in common with other binary formats that have become more popular. Things like protobuf or message pack. It has features like being a tag length value format, has compact encoding of integers. It allows you to embed strings or binary blobs without needing to escape and unescape them. It has support for arbitrary serialization of types as opaque data. All good stuff. But it also has a bunch of features that fit in really well in Ruby, like native support for hashes and arrays, and also hashes with default values and stuff like that. Has multiple ways to serialize arbitrary classes, either by giving a list of instance variables or completely custom, here's a binary string, there's a binary string, here's an object, there's an object, do whatever you want. It has support for deduplicating objects and symbols in the stream. And built-in support for instance variables, because we're Rubyists. All of our stuff is stored in instance variables eventually. And also, we're Rubyists. We like just being able to do things at runtime, and dynamism means fun, right? Marshal's got support for that. So, okay. Should you use this gem-safe Marshal module to make Marshal safer? Please don't. I put on my official security engineer hat. Please don't. It's slow. It has a bunch of Marshal features that are intentionally unimplemented because Ruby gems didn't need them, and also I was lazy and didn't feel like implementing them. And finally, I wrote the code, so there's really no promise at all that it's any good. But if you need to read in Marshal files anyway, it's probably better than using marshal.load on untrusted input. And if you're interested, gem-safe Marshal is available in Ruby Gems 3.5, which is included in Ruby 3.3. So surprise, surprise, you've been using this code I've been talking about all along. And now, I did a really good job with time here. I'm going to say thank you for following along and laughing at my bad jokes in the only appropriate way I could think of with a bunch of Marshal.